Hi, everybody. Welcome to section 3.1, self-check exercises. So let's go ahead and get started with number one. So number one says, find, if any exists, the critical values of this function. So we have a function f of x equals x to the fourth plus 4x cubed plus 4x squared. So the first thing we want to do to find a critical value is get the first derivative. So to take the first derivative, what this becomes is just 4x cubed plus 12x squared plus 8x. Okay, so we find the first derivative, and then critical values, recall, is when your x values that make your first derivative equal to zero. So what I need to do then is set this equal to zero, right? So I'll say set f prime of x equal to zero. And what we would have is 4x cubed plus 12x squared plus 8x equals 0. Okay, so now it's just a matter of using algebra to get these x values. So one thing they all have in common is some sort of 4x, right? They all have a 4 in common and they all have an x with it. So what I'm going to do is factor out a 4x. So this would be x squared plus 3x plus 2 equals 0. So now I have two options. I have 4x equals 0, and I have x squared plus 3x plus 2 equals 0. Okay, so on this left side, I have 4x equals 0, so I could just divide by 4. And what this becomes is just x equals 0. And on this right side, I have to do a little more factoring, right? So I typically do a little crisscross. So I want to find two numbers that multiply to 2 and add up to 3, multiply to 2, and then add up to 3. So this would be just 2 and 1. So this would become x plus 2 and x plus 1 equals 0. And that means I'll have x plus 2 equals 0 and x plus 1 equals 0. And then, minus 2 to both sides. I get x equals negative 2. And then I subtract 1 from both sides here. And I get x equals negative 1. All right, so here are my critical values. So let me write that out. So critical values are x equals 0, negative 1, and negative 2. Okay, great. Now let's go ahead and branch upon this. So determine the intervals of which the function is increasing or decreasing. So this is where I'm going to need my critical values again, but I'm also going to need to know whether we are increasing or decreasing around that to determine the max or min. So same thing. We want to determine increasing or decreasing. You just want to take this one step at a time. And the first step is always find critical values. So that's always the first step. Find critical values. So I need to take the first derivative of that function, f of x. So that would just be, or I'll write it out. This is f of x equals 2x cubed plus 15x squared. I need to find the first derivative. So this would just be 6x squared plus 30x. Okay, so remember I need to set this equal to 0 to find that critical value. So this becomes 6x squared plus 30x equals 0. And now I just need to solve for x. So one thing they have in common is 6x, right? They both have 6 in common and they both have x in common. So I can factor out a 6x. So 6x, x plus 5 equals 0. And now I can just isolate both and solve. So 6x equals 0 and x plus 5 equals 0. So this would be, I'm dividing 6 to both sides, which is just going to be 0. And then I'm subtracting 5 to both sides. So x equals 0 and x equals 5. So these are my critical values. Okay, so that's my first part. The second part is where I need to determine where it's increasing or decreasing at. And this is when I need to have a number line. So 2 is number line using the first derivative test. Okay, so here we'll have our number line. It'll be a little longer because we have a couple numbers to work with, right? Remember, we're going off to negative infinity and infinity. So this is where I'll draw my critical value. So here is, let's say 0. And here is -5. All right, so let me just go ahead and pick some points around this that are easy to work with. So between -5 and 0, I guess I'll do like -1. To the right of 0, I'll do 1. They're just easy to work with. And then for -5, to the left of that, I'll choose like -6. Okay, but here's where we want to plug these into our first derivative so that we can see whether they're increasing or decreasing. So, we'll see. We'll say test first derivative. So go off to the side and plug these guys in purple in. So f of -6, we're going to plug that into our first derivative, which is this guy. All right, that's the first derivative test. We're plugging it into the first derivative. So this would be 6 times -6 squared plus 30 times -6. And what you would end up with all the PEMDAS math is 36, which is positive, which means we are increasing. So I'm gonna come up here and draw a little arrow, meaning increase. Okay, so make sure you're working out this step correctly, okay? So now I'm gonna plug in -1. Remember, I'm not plugging in these guys because I know if I plug them in, it's just gonna be 0, right? Because we just found that they make the derivative equal to 0. So if I plug in -1, I'll get 6 times -1 squared plus 30 times -1. And what this ends up being is -24. So remember, I don't really care about what the value is. I just want to know if it's negative or positive. So at -1, it's actually negative. So I'm going to draw an arrow down here, which means it's decreasing. All right, let's check out this last one. So this is f of 1, should be quite similar. So 6 times 1 squared plus 30 times 1. And what this ends up being is 36, which is positive, but that just means it's increasing. So we are increasing till 5, decreasing after 5, and then increasing after 0. So what this means is, this isn't part of the question, but you can identify that this is going to be, it looks something like this, right? So this is going to be a max. And likewise, it looks something like this, right? So this is going to be a min. But we're just talking about increase, decrease. So let's go ahead and write that in a statement. So what we would say here is increasing on, coming from negative infinity all the way to 5. Right? We're increasing from negative infinity to -5. Remember, we're talking about these guys. Be careful not to write your purple ones. All right, those are just random test points. So this would just be increasing negative infinity to -5 and we are also increasing from 0 to infinity. Okay, based off of our increasing from 0 to infinity. All right, so decreasing, where are we decreasing now? We're really only decreasing in one part from -5 to 0, right? That's just this down arrow right here that we found. So we're just decreasing from -5 to 0. And that is our solution. Okay, so it's putting together question 1, adding a little something different with question 2 about increase, decrease. Now question 3 is about another part where we're identifying what the max or min are, which is sort of what we did in green right here. So we're gonna do the same exact process, determine what the max or min are like we did, but then it's a matter of putting in x, y coordinate points. So we'll just find the y value at the end. But we're gonna do the same exact process for this question. So same thing, step 1. What's step 1 again? Find critical values. All right, that's step 1. So I have f of x equals x cubed minus 9x squared, and I need to find the first derivative of that. So it'll be 3x squared minus 18x. And I need to set this right equal to 0 and solve for x. So I'll have 3x squared minus 18x equals 0. Okay, so be careful here. Don't move over the 18x, right? You'll be losing an x value. So you want to just keep everything equal to 0 and use your algebra to factor it out. So I know that each of these have a 3x in common. So I'm going to take out a 3x. This would be x minus 6 equals 0. You can double check your work. If you distribute that back in, you'll get 3x squared minus 18x. But then you can just isolate these. So you have 3x equals 0, and then x minus 6 equals 0, and just solve for them. So divided by 3 to both sides, you'll get x equals 0. And if you add 6 to both sides, you'll get x equals 6. So your critical values are x equals 0 and 6. Okay, so step 2 is that number line. So step 2 is that number line. So here we have a number line. Right? My critical values are 6 and 0. Let me move this over a bit. And 0. Okay. And you want to test some x values with your first derivative. So easy ones to pick. Always pick some easy ones. You could pick like -1. You could pick 1. All right, those are easy. And then maybe like something like 10. 10 is an easy number to work with too because it's 0. But okay, so let's go ahead and plug these numbers in and see what we will end up with. So if I plug in -1 into our first derivative, which is this guy right here, right? Let's see what we get. 3 times -1 squared minus 18 times -1, and we end up with positive 21. All right, so remember, it's not really about the value, it's about positive or negative. So this is positive, which means it's increasing. So I'm gonna come here and make a increasing annotation. All right, next one is plugging in 1, right? So I'm going to have 3 times 1 squared minus 18 times 1. This is going to be a negative 15, right? So this is negative, and this is decreasing. So a positive 1, we're going to have a decrease. All right, so last one is 10. So I'm going to plug 10 into this. So that would be 3 times 10 squared minus 18 times 10. All right, this ends up being like 300 minus 180, which is 120. This is positive, which means it's increasing. Okay, so we found that before 0, it's increasing, and after 0, it's decreasing. So that means it's going to look something like that, right? So this means we have a max here. All right, and likewise, after 0, we are decreasing, and oops, I kind of wrote this in the wrong place. It's a little spaced out. Let me fix this. Okay, so we found that after 0 is decreasing to 6, and then after 6 is decreasing, so it's going to look something like that. So this means that at 6, it's a min. Okay, so lastly, we have that set up. So now it's the point of just finding the XY coordinates where these max and min are. So let's do that for the last step, and that's really just plugging in those critical values that we found here and here into our function and getting the real coordinate points. So I'll say something like find y values. So I'm going to, so we know we have a max at x equals 0, min at x equals 6, right? So I need to plug these guys into f of x equals x cubed minus 9x squared to get the y value. Okay, so let's go ahead and try that out. So I have f of 0 equals 0 cubed minus 9 times 0 squared, which is just 0. So I have the point 0, comma 0. Next one is 6. So I'm going to plug 6 into here, f of x. So this becomes like 216 minus 9 times 36, which ends up being negative 108. So this is the coordinate point 6, negative 108. So putting this all together, we have a relative. Which one is 0 again? 0 is the max, right? So relative max at 0, comma 0, and a relative min at 6, comma negative 108. And that's our answer for number 3. Okay, so that's it for the self-check. Try these out, and I'll see you next time. Thank you.